Good evening, ma'am.
Good evening, ma'am.
Good evening, guys. How are you?
Fine, ma'am.
Good morning.
All right, turn on your cameras, each one. Yuvraj, what happened, bache?
Nothing, ma'am. I just have high fever.
Oh, okay. So, we all know that we know that atom is the smallest unit of matter, right? Or should I say, um, you can break up an atom into electrons, protons, and neutrons, but that particular setup, which is the constituent making thing of the of any substance, is actually an atom. It's not electrons, it is not protons alone, it is not neutrons alone, it is in a certain combination called as the atom, right? Okay. Now many attempts have been made in the past to understand most fundamental things, right? And this actually serves as a great lesson in our lives that whenever we want to understand the most toughest of all stuff, right? It always starts from the most fundamental, right? You can do a PhD in any subject, right? But then you need to understand what is the fundamental basis of that particular PhD, right? What you are looking for, and in what stream or in what field are you, intending to do your work, right? So similarly, when you have chosen, I mean, I always believe that the class 12, the class 11th and the class 12 CBSE syllabus or the JE syllabus or the NEET syllabus is very wonderfully set. It's just the most beautifully set curriculum ever. Why? Because now you are beginning to set foot into the, you've chosen a career for yourself. That is the science career, right? So they are actually, making you actually go back and start from the very fundamental basics. Mole is the central thing of all chemistry. So first they told you about the mole, right? And how things are occurring in different forms, in solutions, in solids, in gaseous forms. And they told you laws of combination, right? Now they are trying to tell you to go to even more fundamental stuff, atom and the structure of atom and its discovery, right? And how we can arrange different electrons in different ways in a particular atom, right? So this whole chapter is known as structure of atom. We already know a lot about the structure of atom, right? We know the J.J. Thomson model, right? And we know the Rutherford model. We know some basics of the Bohr model also, correct? But in this chapter, we would also know how electron was discovered, how proton was discovered, how neutron was discovered, correct? And how the charge on an electron was discovered. That is also something which is very fundamental, right? A beautiful experiment I had already mentioned, that is the Millikan oil drop experiment was made for this, right? To find out the charge on an electron, right? So this is what we are all going to study, and different models of an atom. And a lot of students always ask me, if Thomson was such a model which has not done much, so why are we still studying it, right? So if we let's say did not know where cotton came from, or what was made earlier of cotton, then we would never be able to make comfortable clothing right now, right? It's because we know that such and such things were existing and they were uncomfortable. That's how you could make better things, right? Correct?
Yes, ma'am.
Earlier we used to have cotton tops, and a lot of people were you must have seen the athletes used to wear cotton like long ago. Okay, now you have those beautiful dry fit clothes, right, where the entire amount of sweat can be absorbed, right? Those are worn by athletes. So we've come of age. And when do you come of age? When you know your mistakes, and when you know that a particular theory contributed this was its positive point and this was its negative point, and what you need to improve upon. And that is why you start from the most theory which you feel a lot of people know this is a redundant theory. It's not. It taught you a lot about many things. Then only you go to the most advanced and the developed one, or the one which is accepted of, right? Correct? And until unless you know the basics, you will not be able to appreciate the theory which is right now being accepted. That is also one thing. If I straight away teach you the Schrodinger wave model, you will never understand why we are studying it right now. What is the beauty of this study? Right? So this everything has to be accepted with an open mind, right? Same thing will happen when we will study chemical bonding. Because you'll study Lewis dot structure also, and you could question, ma'am, why are you teaching all this? I will just take 5 minutes for that also. But it is important, right? In order to appreciate whatever is going on right now, it is important for you to study what was the most basic thing and why people thought of that thing at that particular point in time. You get my point? So that also we will do. Okay. So right now, let's go to okay. Structure of atom. We are going to do this. Okay. Now, when we do this, we always talk about an atom. And the first model which we came across was the J.J. Thomson. Plum pudding, as we call it. Or what is the other name? Watermelon model. Now, before we move into this and the discussion of this, it will only take a very small time. I want you to know that J.J. Thomson, Sir J.J. Thomson was given knighthood also, and he is credited with the discovery of the electrons. Although, let me be very clear to you that it actually is not involved in the very first discovery of electrons. It was known way earlier. But science has been notorious always to give credit to people who are, up in hierarchy, right? So, a very great example I can take of Dr. ECG Sudarshan. 12 to 13-time nominee of the Nobel Prize, but never was awarded, right? Great Indian scientist. So only Indian scientists who went outside and who did work outside have been nominated, and they have been, given Nobel Prizes, like Dr. Chandrasekhar, right? So he was awarded the Nobel Prize. So yes, this is also less like science has been maligned with politics.
ఫస్ట్ నుండి లాస్ట్ వరకు చెప్తున్నా తెలుసు ఆల్రెడీ కానీ వింటున్నా ఆయన నోట్స్ రాసుకుంటాం వెళ్ళ కూర్చొని.
Advaita, can you mute yourself? Okay. So this is something that we must learn, that science is maligned with a lot of politics, right? So nevertheless, since now we are so informed and India will be the next superpower, so expecting more Nobel Prizes in this field, yeah. So, but you must know that J.J. Thomson is not the only one and not the first one, right? To experience that electrons were negatively charged, and he discovered it. That's not the first one. So the very first person to do it was William Crookes. So he discovered the cathode ray discharge tube experiment. And the entire Europe was actually doing this experiment because it was very cheap. And Sir Michael Faraday also. I don't know if you know the story of Sir Michael Faraday. Sir Michael Faraday used to work in the most amazing human being, apart from Madame Curie, to exist and have lived on this earth, is Sir Michael Faraday and Madame Marie Curie. Is because if you see the photo of 1927 Solvay conference, you can see everyone over there. It is such a beautiful picture. It's actually the wallpaper of my laptop also. So it's like one woman and all the other male scientists. That includes Heisenberg, Bohr, Schrodinger, Sir Einstein, everyone you can think of, J.C. Maxwell. Everybody was there. Such a phenomenal photo. So all the great brains in one photo, and there's just this one lady fighting her position into science. So that is why that's what makes her great. And I don't know if you know this, but Madame Marie Curie's casket in which you keep the dead body was made of lead, because her body was emitting so much of radiation even after death, so that her casket was made of lead. So such was her passion. So she used to keep uranium in her pocket. You all know that, right? Because she did not know that it was radioactive until she discovered it. And she's the first person to have won the Nobel Prize with her husband, Sir Pierre Curie, and with her daughter, Irene Curie. So twice Nobel Prize holder. And her 8th generation now, they all are scientists. Big names in the world of science. So you know how one lady can change. We say, educate one woman and she will educate one whole family. Now that was one woman educating all 8, generations. So these are great people. This is what great people are made of, right? And then there is Sir Michael Faraday. Michael Faraday used to work as a boy, didn't have much money, used to work in that, those old bookstore, what we know as Kabadi ki dukan, right? Michael Faraday used to work over there, and he was so fond of reading that he used to keep reading from there only. And then he discovered Faraday's laws. And then he went to the university professors and he said that, hey, can you just accept this? And they said, no, we cannot accept it because you don't have a formal degree. Then he went on to get formal degrees and everything, and he just published his laws and everything. And then the same university people, they said, we want to honor you with a doctorate degree and a professor job in our university, which he finally refused. He said, you did not accept, so I'm not going to come to your university. So people were begging him to be a professor in their universities. So what a comeback. And yes, this is great people. This is how great people live. Yes. So everybody was doing this CRT experiment in Europe, right? When we talk of J.J. Thomson's plum coating a watermelon model, before that, I told you to make a table of electron, proton, neutron, mass, charge. Can you do that? Can you write, please? Quickly finish it up. Quickly write it down, guys. Okay. What is the charge on an electron? What's the SI unit of charge? Yes, Rajani.
Then for electron, it will be minus 1.602 into 10 to the power minus 19 coulombs.
So coulomb is the SI unit. Yes.
Yes, ma'am.
Yes, ma'am.
And what is the CGS unit of charge, better? Anybody? It is ESU, electrostatic units. Okay. This is the CGS unit of charge. Now the same charge in plus, it is the charge on proton, right? Plus 1.602 into 10 raised to power minus 19 coulombs. And neutron, it is 0. Neutron is neutral, of course. Oh, I have written mass and charge opposite. Mass of an electron, minus 31 kilogram.
Yes, ma'am.
Yeah. And mass of proton is 1837 times the mass of electron, which is 1.66 into 10, roughly minus 27 kilogram. Yeah.
Yeah.
And mass of proton is roughly equal to mass of neutron. Okay, fine. Clear, beta? Any doubt?
No, ma'am.
Okay. Now, if we go to this watermelon model, can someone tell me what it said actually, what J.J. Thomson had proposed in this model? Please tell me. Yes, Arinjaya, please tell.
Ma'am, he basically said that there was like a positively charged sphere and the electrons were embedded in it, and he said that the positive and negative charges are equal in magnitude, and thus the atom as a whole is electrically neutral.
Beautiful. Wonderfully put. Okay. Now, can someone tell me the biggest advantage or the biggest pro factor of this particular model, please? Yes. Who will tell? Kindly raise your hands if you want to answer. Bhavesh, please.
Ma'am, the model is able to tell that both electrons and protons have equal magnitude and they got cancelled, and the atom is stable.
So basically, electrical neutrality is one of the biggest pro factors of this particular model, right? He could prove that there is no excess charge which is there existing in my model. It is electric that the atom is electrically neutral, totally electrically neutral. Okay, fine, clear. Not a problem.
No, ma'am.
Okay. What was the biggest disadvantage of this model? Gaurangi, please tell.
Ma'am, is it that there were no neutrons in his model?
Okay, but with the existing, whatever Arinjia said in those two lines, right, that there was a, let's say the red portion of the watermelon, if we assume it to be called as the watermelon model, then the red portion is the positive charge and the seeds actually, there would be the negatively charged electrons. Just in the
Right.
existing model, whatever he explained, what was the advantage and what was the disadvantage?
Can I tell?
एक second, let everybody contribute. Isabel, because I told everybody to read it and I'm actually observing who all have paid heed to what I said and who all are answering. Good, I'm actually observing that. Isabel, tell me.
Ma'am, the positive charge would not be able to hold together because it's all positive. So that was one disadvantage. So the atom would not be stable.
Okay, anybody would want to? Shakti, can you put it in your words?
Ma'am,
I think the wording is a bit off, but
about the atomic stability, he did not explain how it could exist without collapsing.
okay. Aradhya, can you explain?
Ma'am, it didn't tell us about the presence of a nucleus in the atom.
Okay, Srijani.
It did not, it said that the mass of the mass is concentrated throughout the atom, or the charge of the proton, the charge and mass is concentrated throughout the atom, but in the real case, it's concentrated in the nucleus.
No, like whatever he proposed was that a red portion, which is of the watermelon, which is positively charged. Can it actually exist with the electrons? It cannot.
No.
Positive and negative charges cannot exist together. It's not possible at all. No. Do you think it is possible?
No, ma'am.
They would end up, neutralizing each other, and they would just, because they are just opposite in charge, rest everything, and their protons are heavier in mass. They would just eat the electrons up, right?
Yeah.
Because considering they are just negatively charged and having some mass, the protons would actually eat up the electrons totally. So leave aside nucleus, that you know now. I'm saying in his model only, if you were just independently considering his model, one could say that the coexistence of electrons and protons together, protons, is not justified. Leave aside the nucleus, all these things is, no, I'm not considering like that. I'm not considering. I'm just considering this simple disadvantage that, that is existing in whatever he said. Because whenever we discuss a theory or a model, it's just whatever the model says, advantage and disadvantage. Not what you already know and you want to come back. No. Let's just see the model independently. Yeah, and then talk about it. Okay. Now let's talk about Rutherford's model. Gold foil experiment. Little history about Rutherford. Rich guy. Not everybody can afford gold foils. Okay. Obviously. His father and his mother owned farms, right? So he's a rich man. Okay. Plus, if you have heard about something called radioactivity. Now, to measure radioactivity, the very basic counter which is there, it's called Geiger and Muller counter. Now, these two guys, Geiger and Muller, were assistants to Rutherford. So Giger, Muller, and Arsden. These were the three people actually. Giger, Muller, and Arsden were the three people who were assistants to Rutherford. And you can imagine that he certainly was a rich man, right? Michael Faraday could only do the electron discharge, cathode ray discharge tube experiment. He could not do this coil experiment. Why? He could not afford. See how science takes turns, right? So one can understand that from the history we can take lessons. For science, we need money. We need money. So scientists are offered with this poor guy sitting in some poor house. Arey Baba, nahi. Scientists need high-tech stuff. They need it. And for that comes from money. So whenever you are, so why am I telling you this? Is because whenever you are talking to a young child and inspiring him or her for science, then make sure to tell them that you should, and make sure you tell them in this way that you are giving, there is something called, we tend to give, on many occasions, it's our culture to give food to other people, right? Right? We distribute food, sweets. That culture is good, very good. It's very nice. But now I think as Indians, we need to give one more thing. We need to give the, it's called daan. In Hindi, it's called daan, right? Offering, right? That offering should be of science. So that every person in the whole wide world, or who's an Indian, or whoever you are interacting with, your cousins, your youngsters in your house, should know what science is all about. Science is not about some poor scientist walking with a jhola. No, 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 no. Let's change the image of science, right? And whatever daan you want to give, that should be the daan of science. That should be the offering of science and knowledge that you possess, okay? So that is why I keep on saying this. It's filled with a lot of lessons. So now, had maybe Michael Faraday known, or maybe he was rich, or maybe somebody would have helped him, then science would have taken a different turn right now. Then we'd be studying different people right now, right? You understand? So we are supposed to not just study science, but we are supposed to empower ourselves with money and with a lot of courage and fame, so that we can pursue science in the right way. Now, India is no longer that country who is looked down, a poor country, this third world country. No, 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 no. We are going to rise and shine in science and every other field, okay? So a lot of lessons are being learned from this particular chapter also, right? So this is what we are going to do. We are going to shine like this, okay? So now, Giegel, Murrell, and Arsden were his assistants. This is a rich guy and who loves Thomson. Thomson is, whatever I'm going to do, Thomson is my guru. Whatever I'm going to get, this watermelon model is beautiful model. I will get something from something. I'll design something like that and I will get the results from there. Okay. So he took a gold foil, right? First question, why only a gold foil? Why not aluminium? He doesn't want to brag about how rich he is. Definitely not. Why only a gold foil?
It is a thin
Ma'am, because gold is the most malleable metal.
Most malleable metal. Because this gold foil was just not an ordinary gold foil. It was 1,000 atoms thick. Okay, it was 1,000 atoms thick. Okay, this is important for you to know. So this 1,000 atoms thick can only be of a metal which can be beaten up into that much amount of small size. You get my point or not? Yes.
Yes, ma'am.
Let me just post the image of this. Can you all see this?
Yes, ma'am.
Yes,
Is it
ma'am.
properly visible? The foil experiment?
Yes, ma'am.
Yeah. Now you have, you are hitting the gold foil with a alpha particle. What is an alpha particle, beta?
A helium particle.
Doubly ionized helium.
ionized helium
Doubly
ions.
charged. It is
Ionized helium
doubly charged.
particle.
It is doubly charged helium ion. It is doubly charged He ion. That is He2 plus. Why doubly charged? Why do I need doubly charged, beta? Why do we need it?
There, helium has 2 electrons, and doubly charged means we are removing the 2 electrons. So it
No,
will
but
have
why do I
the-
need it?
Ma'am,
Why do I
we'll be
specifically need doubly
testing
charged?
using the protons or the nucleus.
See, the thing is that now as you study this model deeper, you will understand that, he was trying to, Rutherford was trying to, he was he got to know of the nucleus, right? Nucleus is positively charged. That's what he got to know, right? He did not expect this result at all, right? So he definitely knew that there are positive charges and there are negative charges in an atom. Had he taken everything in one particular atom, that is, had he took, the helium atom, then what would have been there? Then helium would be attracted to something and repelled by something, isn't it? Would be repelled by electrons, would be attracted to the nucleus, would be attracted to the proton, so to say, if Thomson was his, ideal. So he would not find anything. If he removed everything, right, from a particular atom, and there are only positive charges now. Can you see the number of electrons are 0, number of protons are 2 here, and number of neutrons are 2 here. Now we know this. If he removed all the electrons, then he would be able to observe clearly what exactly is getting attracted to, what exactly it is getting repelled to, right? For that, it was mandatory to remove 2 electrons. Now, removing 2 electrons is not that he took a helium atom and started removing 2 electrons. No. He took a alpha particle emitter, which is uranium. Uranium undergoes radioactive decay. To give you uranium and this helium 2 plus ions, that is alpha particles, and thorium. Okay. Now, when he passed the, the alpha particles to through the gold foil, obviously alpha particles had to, whatever he noticed, wherever the alpha particles would go, he had to put something. So in order to detect it, right? So that was something called a detecting screen, which is made up of zinc sulfide. Zinc sulfide tends to glow when a particle hits it. Okay. It shows the property of fluorescence. Okay. So zinc sulfide particles glow when a charged particle hits it. Okay. Now, Rutherford is credited with the discovery of nucleus or the protons. He used the Greek term protos for his findings. Also, he is popularly known as the father of nuclear physics. It's popularly called as the father of nuclear physics. Okay. Now, when to his shock, it was a shock for him because he was like, okay, some of it is going to get attracted, some of it is going to get repelled. No problem. I'm going to have a wonderful time doing the experiment. I'm going to reaffirm what Sir Thomson has done. And yes, but science is not like an English dictionary. Whatever is there, you have to believe. The meaning of BUT is but PUT is put. We have to know. We have to understand. We have to speak it like that. Nobody knows what is actually going on. Have you ever asked why? Why knife has a K, but is pronounced as NIFE? Funny language, right? English is certainly a very funny language. But if you see, our Indian language is beautiful. Everything, even every single dot has a sound to it. Right? If you study Hindi literature, if Hindi, the characters, the 33, there are 26 in English and 33 in Hindi. If you see, every single dot even has a sound. And one is pronounced, one sound is from here and the other is from here. This and Chandrabindu, both have different sound. The Chandrabindu is from here, the sound, and the Bindi is from here. It is so scientific. It is so beautiful. Yeah. Got it? So one has to really think. Huh? 1 second. My screen share went off. Hold on. So this is what. All right. So now father of nuclear physics, and coming back to where we were, right? So Rutherford was shocked when he had a few observations and he concluded a few things. Can someone tell me what was the first observation?
There is a much hollow space between an atom.
Sorry, what?
Ma'am, there is a hollow space in an atom as many of the particles move straight away without repelling.
The observation is this. What you are saying is a conclusion. Most of the alpha particles
Through the atom.
pass right through the atom. Right? So that means most of the space in an atom is empty. Correct? Got it? What was the second observation? Please, 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 you have to understand, I'm talking about observation. I'm not talking about conclusion. Okay.
Yes,
Can I
Hanji?
answer?
ma'am, some of the alpha particles were deflected by small angles.
Okay. Some of the alpha particles got deflected by some angles. What is the conclusion? Anybody? Abhijay, please tell me.
This concludes that most of the mass inside, like most of the space inside the atom is empty, and the mass is
No, that
concentrated.
is the first one. That is no, wrong. That is the first one. I'm talking about the second one. Second conclusion.
And like there's some concentrated mass that resides in the center of the atom.
Yes, there is some concentrated mass, some concentrated positive charge. Positive charge is very important to mention, okay? Because that is why they are getting repelled at small angles, right? You can see here. I hope they've shown it in this. Some angles are not shown. It is shown here, right? Can you see this? Deflection by small angles, yes. That means there's some concentrated positive charge and the alpha particles are brushing right past it. Okay, fine.
Yes, ma'am.
What is the final observation, beta?
Can I say?
Some alpha particle retraces their path.
1 of every
So
20,000 alpha particles were rebounding.
1 in 20,000 alpha particles rebound. Rebound means deflected by angle of 180. Huh? Okay. So what is the conclusion over here? Grishma, can you tell?
The positive charges are concentrated at the center.
Yes. A very small positively charged center exists. Right? Now, can you imagine 1 in 20,000, how less that is? So that means the nucleus is very, very small. So that means the nucleus is, you can draw the analogy that the nucleus is like, what you can say, it is like, let's say a cricket ball kept at the center of the pitch is the nucleus and the entire stadium is the atom. Can you draw the analogy? How small the nucleus is? Now I have one question to ask you. Do you actually think Rutherford did not know about the neutrons? Do you really think so?
Ma'am, he could not prove it somehow, but he must have known that
Prove it.
neutrons
Yes,
exist.
he must have known it, because to say and to find out particular thing that there is a positively charged center, and we always say the same charges, they are repelling each other. He also knew it. What is the great thing to not know about it? So that means he knew that there is a glue which is holding on to the protons. Some glue is there. He did not know it could be called as neutrons. He did not know the other things, but he certainly knew that there is something. There is certainly something which is holding on to the protons. Whether it is neutral, he did not know 100%. How they are holding, he did not know 100%. So he could not prove it. And science runs on proof, right? You give me a proof and science will run on it. Get my point?
And what
So
is
it's
the
not that,
difference
okay.
between second and third
Sorry,
conclusion?
what?
What's the difference
Sorry, what?
between the second and third conclusion?
I can't hear you actually. What are you saying?
I'm saying, what's the difference between the second and third conclusion of this model?
Brushing past small angles mean it's not directly in contact. They're just brushing past it. Maybe at the corners of it, at the corners of that positively charged sphere. But there's a head-on collision, so definitely that is, when that will be rebound by repulsion, right? Because alpha particle is totally positively charged. That's what.
Can you show the second conclusion?
Here. Okay.
Yes, ma'am. Thank you.
Okay. Yeah. Now, has he talked about the electrons at all till now? No.
No.
Because his entire model is centered around, positively charged species, which is the this alpha particles. Yeah. So he definitely proposed that the electrons are negatively charged species and they are, revolving around the nucleus, right? Okay. Fine. But my question to you is, you have read this before in gravitation chapter of class 9th. How does Earth keep on revolving around the moon without falling into it? What is happening? Can anybody tell?
There's a centripetal and a
Is it
centrifugal
because of
force.
centripetal force?
So what is it with the centripetal force? Is it just the centripetal force? What is this? Hold on. What is centripetal force? Define it for me.
Ma'am, when a body is moving in a circular path, in a uniform circular motion, for example, a stone wall with a string, and then the force acting on the body radially invert towards the center of the circular path is the centripetal force.
What is centrifugal force?
Ma'am, it is a fictitious force which we assume which is acting on the body in an outward direction so as to keep the body in a state of rest. Like
State of rest.
no, so the net force on the body is zero.
So it is a fictitious force which is required, which is equivalent to the centripetal force required to just pull out the body front, which is moving in a circular motion, correct?
Yes,
Okay.
ma'am.
Now, this centripetal force, what do I do with the centripetal force?
It keeps the Earth in the
But sun
orbit.
is too big, yeah. It will pull the Earth into inside, especially Mercury. Mercury is going to be sucked in. It's the first planet. So, what do I do only with the centripetal force? What does Mercury do with the centripetal force? Yes, Isabel.
It's going to be kept in the orbit. That's what I said.
How? That's the exact thing that I'm asking, Ruchik.
Ma'am, we assume that
You
the
have-
gravity, like the gravitational force, is acting as the centrifugal force.
Can you tell me with what gravitational force are you talking about?
The planets, like each of the planets. Actually, no, sorry.
Think.
Is it because of the mass of each planet and it's proportional, the force?
Sorry, mass of what? Sorry?
Ma'am, the force is proportional to the mass, so I guess because of that, it's not
What is
falling into
force? Minute, what is the force called?
gravitational force.
No, what is the formula of that gravitation? Because we are not able to put it in the right words. What is that gravitation?
GMM by R square, where M and M are
That is not, you can just call it, please, the universal law of gravitation that that is there existent with every single body. Yeah, that has to be equal to mv square by r, which is the centripetal force. Otherwise, every planet would definitely fall into it, and the masses would be equivalent to this, right? That would be equivalent to the speed with which they are revolving around the sun, right? Correct now?
Yes.
Correct.
Ma'am, could you please tell this once more?
See, the thing is that every single body in the universe is attracting every other body. This is universal law of gravitation, right?
Yes, ma'am.
Yes,
And
ma'am.
what is this? This is gravitational constant. Who gave this? Anyone? Anji?
Henry Cavendish.
Henry Cavendish. Yes. Small things you must know, right? So, see, the thing is that what I'm trying to say is only when this attractive force between between the sun and a planet, right, which is trying to revolve around it, only when it equals the centripetal force which is experienced with which the Earth is revolving around the sun, or the any planet is revolving around the sun. Only when this equals the attractive force, only then can it keep on moving forever, right?
Yes, ma'am.
Otherwise, it's going to definitely fall in. I mean,
Yes.
whatever way it is, either it's going to, if it's too fast, it's going to fall out of the orbit, right? Maybe change its orbit. Or if it is too less, the sun is going to suck it in 100%. Do you appreciate what I just said? Yes.
Yes, ma'am.
Yes.
This is very important to realize. Very important. Okay. Now, Rutherford's model was very highly inspired by the solar system model. That is why it is very often called the solar system model also, right? Very often you can see in NCERT also it says, right? So when can an electron, now the very big disadvantage of this you must have seen or read, that when a charged particle is moving around another charged particle, it is bound to lose energy and it will fall into the nucleus and the atom will stop existing. What is the meaning of that? Can anybody tell? What is the meaning of this? Yes, please. Can anybody tell this?
Can you repeat your
Why
question?
cannot a charged particle keep on moving? Yes, Grishma, can you answer? And
Ma'am,
we
I
know for
don't
sure
know.
the electron is not going to fall into the nucleus, right? We know that. But why doesn't it fall into the nucleus? I want to know that. Take some inspiration from here.
I'm just saying, can I try?
Yeah,
Ma'am, is it
please.
because it will, when it loses its energy, it will not travel at the same speed with the same energy that it is supposed to travel with, so that's why it will fall into the nucleus.
I agree. But the electron is revolving around the nucleus. That is a surety.
Yeah.
How?
Is it because it gets the charge from the shell that it
No.
Ma'am, is it because when it loses its energy, it jumps from like one shell
It is
to
not
another?
losing energy, Baba. It is not losing energy. Don't go ahead. Just stay here in this model with me. Don't go to Bohar. I'll take you to Bohar. Don't worry. We'll go to Bohar ourselves. We'll go to Bohar together. Bohar uncle is waiting for us, but together. Not we'll stay on Rutherford.
Ma'am, can you please repeat the main question?
See, the question is, they say that the disadvantage is that the electron is going to fall into the nucleus. Why? And why it won't? Okay, let's say it doesn't. But why it won't fall into the nucleus? Ye batao. That's the question I want to ask.
No, because it's in the orbit, the path.
If the orbit is not, see, Rutherford did not describe any orbit, Baba. He did not describe any orbit. He only described that, electrons are revolving around it. He did not describe the orbits at all. No, he did not.
Ma'am, is it
I
because
want to know.
of the same?
If we compare it with the solar system model which you explained just now, then is it because the electrostatic force between the nucleus and the electron is equal to the centripetal force experienced by the electron?
That is
Yeah.
absolutely wonderful. Absolutely correct, beta. Very good. Very good. So she understood it, right? So this is the electrostatic force. It is actually nothing but the, analog of that universal law of gravitation. Can you see? Instead of G, we have 1 by 4 pi epsilon naught. Okay.
Yeah.
Q1, Q2 are the charges of the protons and the electron. R square is the radius of the atom, right? Or where the electron is present, is equal to mve square by R. If these two are equal, electron will never fall. Very good, Srijan. If these two are equal, they will never fall. It won't fall at all. Clear hai ki nahi? Okay.
Ma'am, can you explain the formula for the electrostatic force? I didn't understand what the symbols represent.
Wait, I will explain it to you. But this is just, you can just understand for the time being, it is electrostatic force. We will go into the deep details of it. Don't worry, okay? Of attraction between proton and electron. Okay, fine, clear?
Yes.
Ma'am.
So, you can easily find out from here this thing. This is electrostatic force of attraction. Okay. So this is what he did not describe. This is what Rutherford did not describe. That is why the disadvantage became, so he listened to, hey, Rutherford, listen, that, the electron is going to fall into the nucleus. No, it won't fall into the nucleus. This is why it won't fall into the nucleus. Okay, Bhavesh, now you understood. Question and answer both.
Ma'am, I knew the answer, but Shishani told them earlier than me.
No problem. No problem. This is what exactly happened. Srijani and Bhavesh are reminding me of Sir Dmitry Mendeleev and this one. There was this one more scientist. Just that Dmitry Mendeleev's theory came 11 months before the other one. So Dmitry Mendeleev became Dmitry Mendeleev and the other one became the other scientist. I'm not able to. It's another French scientist. Oh God, I forgot the name. A.E.B. Shakotwa. It's a French scientist. So he knew the things, but 11 months. So my there's this there was this person who used to work with us, and she made a compound. And in PhD, you have to make new compounds. She made a new compound. She made a compound. 8 months later, somebody had already made it, and then she went on to my PhD boss, and she said, "Sir, I have made it. I have made the compound." She's very happy. So then our PhD boss was like very super intelligent. He's actually the defense advisor to right now the defense minister also, right, and the scientific defense advisor right now in the government of India. So he said that, if you make a cake, he very beautifully used to put it, if you make a cake and put it on the table, so I will not spare that cake. I will cut it and I will eat it. So he said that, if you have a theory, just say it, just put it out in public. You will learn in the next model, which is the Bohr model. Bohr exactly did the same thing. Whatever he had, he just put it out in public. He didn't wait. And then Sir J.C. Maxwell said to Bohr, hey, listen, you are going too far with this. You are, too many constants are there in your theory. What will you do? Then Bohr said, hey, listen, I have a lot of, I've done a lot of work on this. I can't go back, okay? If I go back, the world will not know. So this has to be get published. We published the whole thing. And some of it was definitely correct. Some of it was wrong. Yeah. So that's why I keep on telling every one of you, each one of you, beta, whatever you have to share, you please share. Right? If it's wrong, let it be. Nobody's judging you, Baba. I'm not judging you. Say it. It doesn't have to be perfect all the time. No problem. And sometimes when it's perfect, I will definitely appreciate it. Because it has to be appreciated, right? Otherwise, I love the responses from my students. So those who are participating, trust me or not, I have each one's name written in my diaries. Okay, those who participate in my class, those who do well in my class, it's there. It's there. Right? I know everyone. And slowly and surely you will come to know Swarndeep ma'am is one teacher who knows every single student's attendance without keeping a note of it, and who knows who is participating, how many questions you have answered. It's just a God's gift. I know the child, right? Even when somebody asks me a question, I know how much they have read. That's experience. That's not God's gift. That's experience. That comes from, whatever, how many students we keep on seeing, right? So this is what I need from all of you. And Bhavesh, I know that you knew the answer, but you were not able to put it in the right words. I know. But it's good. It's good that all of you are interacting so much. And I absolutely tremendously love it and appreciate it. Right? So these are the advantages and disadvantages of the Rutherford's theory. And what a great man he was, right? You can now understand. It is always, there is I don't know whether you know the singer Gurdas Mann or not. He sang a song with Diljit. There's a word in it that lot of people learn English and they forget their own native language. And they say, oh, we don't know our native. We just know English. We can speak in English. So he says in that song, we should learn every language, but we should not forget the language where we came from. Yeah. Says it in a beautiful line, right? I'll tell you someday in Punjabi. Beautifully he puts it. Right. So that's what we keep on saying, once Rutherford got to know something new only because he treated Thomson as his guru or as an ideal. If he was like, Arey, Thomson is stupid, I'll find out something on my own. No. Only when you learn the theories before and you treat them as a base, will you learn something new? Will you find something new? Okay. Got it? So I will end the session over here. And it was superb today, and we finished 2 things. I'll be starting formally with the electromagnetic spectrum and the Bohr's theory in combination in the next lecture, which is tomorrow at 7 p.m., not 6 p.m., 7 p.m. Okay. And the extra class for mole is at 7 p.m. on Wednesday. Okay, bacha? That is an extra class for those people who have joined late. Okay. If you wish to learn something again, please make sure you join, right? And if you've already understood it, very good, right? And I will be taking up the theory of it. And the questions you can practice from the worksheets that have already been given. Okay, beta? All right. Your link has
Excuse
been
me.
posted on the count of 3, 2. G.
Ma'am, the questions of the test will be discussed on Saturday.
G, bilkul. Yes, absolutely.
Okay, ma'am.
3, 2, 1. ए भावेश, उससे पहले तू ऐसे करेगा नहीं? क्वेश्चन पूछने से पहले मैं ऐसा नहीं करूँ. What is this? On the count of 3, 2, and 1. Chaliye. Beautiful. It's been a pleasure. I will see you tomorrow. Bye-bye, guys. Take care. Good evening.
Thank you, ma'am.
Thank you, ma'am.
Bye.
Thank you.
ma'am.
Bye, ma'am. Thank you.
Thank you.